All right, so let's do some more quadratic examples with nonlinear inequalities. So we have this quadratic, x minus 3 quantity squared is less than 16. Okay? Well, we want to set one side equal to 0, and we're also going to distribute here so that it looks like it's in standard form. So we'll have x minus 3 times x minus 3. Then we're going to subtract 16 from both sides. So we'll have minus 16 is less than, and then 16 minus 16 is 0. And so we're almost ready. This side is equal to 0. We just need to distribute here. X times x is x squared. X times negative 3 and negative 3 times x gives us negative 3x and another negative 3x. So that's negative 6x. Negative 3 times negative 3 is plus 9. And then we have this minus 16, and that's going to be less than 0. Clean it up a little bit here. We get x squared minus 6x plus 9 minus 16 gives us minus 7 is less than 0. This is factorable, so we're looking for two numbers, and you could look it up with Desmos if you want to. Two numbers that multiply to negative 7, but they add up to negative 6. I know that they are negative 7 and positive 1. So we're going to have x minus 7 times x plus 1 is less than 0. So look, negative 7 times positive 1 is negative 7. Negative 7 plus positive 1 is negative 6. And so that means our zeros here, our solutions are x equals 7. Remember how I said you can solve these by reversing the sign here? X is equal to 7, and this one's going to be x is equal to negative 1. So our critical values are 7 and negative 1. And so now we just have to draw our sign chart, negative infinity up to positive infinity. We have two critical values, one here, one here. We'll put negative 1 here and 7 here. And so let's plug in something smaller than negative 1, like negative 2. Okay? We could go back to the original. We could do negative 2 squared. I mean, when I say original, I'm sorry, not this one. We can go to this thing. We don't have to use the factors if we don't want to. So we can do negative 2 squared minus 6 times x, which is negative 2, and then minus 7. Okay? Negative 2 squared is 4. Minus 6 times minus 2 is plus 12, minus 7. 4 plus 12 is 16. Minus 7 is 9. That's a positive number, so we'll put a plus here. Okay? Now we'll pick a number in here. Between negative 1 and 7 is 0. So we can put a 0 here and a 0 here. 0 squared is 0. 6 times 0 is 0. So 0 minus 0 is 0. And 0 minus 7 is just negative 7. So we'll put a minus in here. And then let's pick a number larger than 7, like 8. We'll put an 8 here and an 8 here. 8 squared is 64. Negative 6 times 8 is minus 48. Minus 7. 64 minus 48, that's 16, and 16 minus 7 is 9. That's a positive number, and so we have a positive there. So our sign chart is ready, and now we're looking for, don't go to this one, don't go to the 16, go to the 0. We have to go to the 0. We want less than 0. Less than 0 is negative, and so that's this interval from negative 1 to 7, and so our answer is negative 1 to 7 with parentheses because we do not have the or equal to. Okay? I think we can do just one more example. This question is asking the exact same thing, it's just saying it in different words. It says, for what values of x is the function x squared plus 2x minus 15 positive? Positive just simply means greater than 0. And then it wants to know where is it negative, and that means less than 0. Well, both of these things can be answered with the same sign chart. We just need a sign chart for this quadratic. So we can say, well, x squared plus 2x minus 1 is greater than 0. That'll answer the positive. Then we change it to less than 0, and that'll answer the negative. Well, oh, sorry, that's a 15. Sorry about that. Minus 15. Well, we're looking for two numbers that multiply to negative 15. I'm thinking 3 and 5, okay? But it's got to be negative, so one of them has to be negative. It looks like it's going to be negative 3 and positive 5 because negative 3 plus positive 5 is positive 2. So we're going to have x minus 3 and x plus 5 greater than 0. And so now our solution here is going to be x is equal to 3, and our solution here is x is equal to negative 5. Remember, it's the opposite sign. Then we're going to draw our sign chart. We're going to put negative infinity over here, infinity over here. We're going to put 2 slash marks. Negative 5 is going to go over here. Positive 3 is going to go over here. Okay. Now I'm going to use the factors. I'm going to show you kind of a different way of doing this. We're going to do negative 6. So we're going to try negative 6. That's 1 less than negative 5. Negative 6 minus 3 is negative 9. So that is a negative number. I don't care what number it is. I don't care that it's negative 9. I just know that it's negative. Negative 6 plus 5 is negative 1. Also a negative number, right? And all I care about is the fact that I'm doing a negative times a negative. Well, a negative times a negative is a positive. Now I'll do the same thing here. I'm going to put in 0 because 0 is between negative 5 and 3. But I could do it with another number if I wanted to. I'm going to put 0 in here. 0 minus 3 is negative 3. That's a negative number. 0 plus 5 is positive 5. That's a positive number. And a negative times a positive is a negative. Here I'm going to select a number larger than 3. Let's say 4. 4 minus 3 is 1, positive 1, so that's a positive number. 4 plus 5 is positive 9. That's also a positive number. And a positive times a positive is a positive. And now we have our sign chart. And so now we can identify our positive interval greater than 0. Well, we have 2 intervals. We have negative infinity up to negative 5, and we have 3 up to infinity. So positive, the answer to the x values where f of x is positive, is going to go from negative infinity up to negative 5, parenthesis, because it doesn't have the or equal to, union 3 up to infinity. How about negative? Well, we see it right here. It's from negative 5 up to 3. Negative from negative 5 up to 3. And that is the answer to both of these questions.